Sir, you can give the intro, so no issues.
Okay, okay. Sir. So, warm welcome to all the participants, the national, local, regional, national, and international participants who have understood the need to attend this short-term training program. So, welcome, my dear dignitaries of St. Matheresa Engineering College, Thoothukudi, Vagikulam, India, and Wollo University, Kumbhalsha Institute of Technology, Dese, Ethiopia, and the participants, the various participants who have understood the need to attend this program amid this COVID-19 phase 2 pandemic period. So, welcome you all for the virtual international intensive 3-day program, short term training program on electrical, electronics, computer, civil, and mathematical engineering on 11th May 2021, 12th May 2021, and 13th May 2021, respectively. So, warm welcome to the resource persons. First of all, I should thank them because amid this hard times, they have rightfully accepted the offer. And yes, we are in the hard time. Thanks to Professor C. Tangam, uh, the assistant professor, and the current head of the Department of Electronics and Communication Engineering, Professor B. Arul Rajan, associate professor of ECE, Professor Electa Alice Jairani of ECE department, the associate professor, and then we have Professor Rachel, Professor Anu Joel, Professor Regan, Dr. Karthikeyan. We have Dr. Ananda Babu, Professor John Livingston. We have Professor Vimalan, uh, Professor Satya, and Dr. Kameswari of Kalasalingam Institute. So, warm welcome to all the resource persons present here. And the dignitaries, I should have a special mention. ERC Arun Babu, in his absentia, who is the Managing Director of SCAD Group of Institutions. Dr. K. Jayakumar, General Manager Development, SCAD Group of Institutions. Professor A. George Clinton, Professor Planning Development and Student Affairs, St. Matheresa Engineering College. Dr. Melako Tamane, in his absentia, Scientific Director and rank of Vice President, KIOT Ethiopia. Dr. Habtamu Mohammed, Deputy Scientific Director, KIOT Ethiopia. Dr. Azaman, Director, Research, Community Engagement and Technology Transfer, KIOT Ethiopia. Dr. Prabhakar Sekar, the facilitator and organizer of this program and the Associate Professor of Mechanical Engineering, Wollo University, Kumbhalsha Institute of Technology, Ethiopia. And my dear participants, without you, the event would not have been possible. So, warm welcome to all the dignitaries. Um, Dr. Prabhakar, if you have anything to share, we can share, else we'll start today's session.
Sir, no need of wasting the time, sir. We will start our session, sir.
Okay, fine. So, first of all,
Thank you for your warm welcome, sir.
yeah, yeah, it's okay, sir. So, in these hard times, first of all, we pray to God that God may keep us happy, safe, and healthy, uh, keeping our near and dear ones close together. Maybe we are bonded close together, but we have to be socially distanced apart. So, over to you, Professor Tangam, who will handle a session on uh, IoT robo for smart home environment. So, before starting today's session, let me give you a short introduction about the resource person. Professor C. Tangam completed her diploma in computer technology during 2000 and completed her diploma in Java programming in 2001. She completed her BE in Electronics and Communication Engineering in 2004 and completed her ME in Applied Electronics during 2013. She has served as a quality engineer at Sri Balaji Assemblers and Plastics Chennai during 2005 to 2006 and served as a uh, lecturer at Infant Jesus College of Engineering, National College of Engineering, Marudagalam, and E.R. Perumal Manimegalai College of Engineering and Technology, Hosur. She has also served as a software engineer trainee, IoT simulator developer specialist at Device Networks. Right now, she is serving as an assistant professor and the head of the Department of Electronics and Communication Engineering at St. Madresa Engineering College, Thuthukudi, India. We are grateful to have an industry come technical person, also a teaching faculty as a resource person of session 1 of today's event. So, a warm welcome to Professor C. Tangam, who has rightfully accepted the offer and the need to do this program. Over to you, Professor C. Tangam.
Thank you, Mr. Ananth, to give me such a great introduction. So here I am Tangam, professor of PC department, then Mother Teresa Engineering College. Now I am going to present an IoT robot part smart home environment. Before the presentation, it's of my pleasant immense to welcome you all to gather here to attend this webinar. I hope the next 1 hour will give you a little bit information about IoT applications and how a smart home can be developed by using this IoT. So before starting this webinar, I would like to thank our management, MD sir, Chairman sir, and Principal sir who are giving this opportunity to present this webinar. And also, I want to give my special thanks to Dr. Christo Ananth who motivate me to present this webinar in front of you. Thank you, Christo Ananth sir. So now we can start this webinar. So before going to the smart home automations, I would like to give small introductions about Internet of Things because last 5 years the word IoT is most familiar in the industry. That is, industry people are need to automate their industries by using this IoT application. So what is this IoT? It is an Internet of Things. Yes. IoT is the networks of physical objects or things which are embedded with electronics, software, sensors through the network connectivity that enables these objects to collect and exchange the data. IoT allows the object that to be sensed and controlled remotely across the network infrastructures. We may also use the existing networks to control those objects. So such creates an opportunity for a direct integrations between the physical world and the computer-based system with the improved efficiency, accuracy, and economic benefit. So to develop the IoT applications, the following three components are needed. By using these three components, we can implement the IoT applications in any platform. So first one is the sensor. So the sensors are act as the input to the IoT application because the sensors only collect the various information from our environment which is to be automated. And
Ma'am,
next one,
any fan is there means can you switch off the fan, ma'am? Some air
ah,
noise is there.
yes sir. 1 minute. So now it's clear.
It's okay, ma'am. You can proceed, ma'am.
Yes. The first component is the sensor. So as I told you, which will collect the information of our environment and give to the IoT for processing. Next component is the connectivity. So connectivity is nothing but our internet, our network connection, which will connect the devices to the user. Next one is the people and process. They may process the data collected by the sensors and give the commands remotely to control the devices. So these are the main three components used to develop the any IoT application. So at present scenario, we want to see why this IoT is needed. So this IoT provides us dynamic control of industry and daily life. It improves the resource utilization ratio and also integrate the human society with the physical systems, provide flexible configurations. It acts as a technology integrator and also it connects the universal to a single network. Next, we can go for the home automations. So before implementing the home automations with an IoT, we have to discuss what is meant by this home automation. So home automations is not simply automatically open the door or closing the door or on or off the switches. Here, the IoT home automation, it has an ability to control all the dynamic appliances by electronically through the internet systems. So, the systems may include the complex heating systems, lighting systems, and alarm systems, security systems. All such systems are connected to a central hub and remotely controlled by the user. As I already told you, smart home technology does not simply turn the devices on or off. The smart home can monitor all the what was happened inside the home, and then it can independently or with the predefined buttons operate the presence inside the home as per the user's requirements. So, the smart home IoT consists of the number of sensors that will collect the different types of data from the home, and those data are analyzed properly to recognize the activities of the home or events what was happened inside it. So we can automate the domestic utilization effectively with the reducing cost and also improve the standard of our life. So next we will discuss some example smart devices which are involved in the development of smart home or automated home applications. So some smart devices are listed. The devices are smart steering system, smart light control, smart smoke and fire sensor, in-house control panel, smart sensor, smart thermostat, connected camera. Even cameras also used to take the pictures and give the real-time pictures to the remote user. So we can control all these things using these sensors inside our home. So before developing the smart home, in IoT applications, we have to discuss what are the services needed to develop the smart home. First, for a smart home automated applications, we want to measure the home conditions. So measuring home conditions is nothing but a house is equipped with the number of sensors such as temperature sensor, humidity sensor and light sensors etc. These sensors measure the conditions inside the home and all this data collected by the sensors are visualized and stored in the database by the user anywhere and anytime. We can access those data. Next, once the data is collected by the sensor, then what we have to do? For example, with the collected data, the user come to know that the fan is the user not inside the home at present. Okay, so he come to know the fan is functioning inside his house, but no one is present inside the house. So what the user wants to do? He wants to control the fan. That is, he wants to switch off the fan. So through his mobile, he can switch off the fan. Otherwise, he can set the software to the local processor. If the fan is functioning for a particular amount of time without any persons, it has to be off automatically. So this is called the managing the home appliances from the remote places. So to manage the service allows the user to control all the devices by using some smart devices. So one smart device is this smart actuators. So that are connected to our home appliances. That is our actuators are connected with the lamps and fans. So these smart actuators are the devices such as walls, switches, etc. It may provide a variety of functions such as it may on or off the walls, are producing alarm sounds, or it provides emergency shut down the devices through the digital commands given by the users. Once the home appliances are managed, the decision has to be taken for control. So for that task, we may use the cloud computing technologies to control the devices and collecting the personal data and processing it. So cloud computing technologies also transfer the data from the devices to the internet. We may also use the devices like magnetic and proximity identification cards and other face recognition systems, fingerprint and RFID systems. So let me explain one small example to control the devices using RFID card. So as we all are familiar with the RFID card, so here I will explain you how an RFID card will automatically open the door or close the door. So for here, we need one RFID card as well as RFID reader. So each authorized persons are has an RFID card as well as the RFID reader is located nearer to the door which is to be controlled automatically. First, the person scan the card RFID card to the RFID reader. The scanned ID has been sent to the internet and sent through the internet to the cloud system. So the cloud system compare the received ID with the already stored ID with the database. If those two IDs are same, then only it allows the authorized person to open or close the door. Otherwise, it won't allow the person to control the door. So this is a simple example by using RFID how the user can control the door, open the door or close the door using RFID. Next, so from the above discussion, this is the main component needed to develop the smart home. So smart home can be developed by using various number of sensors, local area networks, internet, processor and smart meter. So we will discuss one by one here. So first component is the sensor. So we all know sensors will collect the information from internal and external earth and measure its home used to measure the home condition. These sensors are connected to the home devices, but these sensors are not the Internet of Things sensor. So the data are collected by all amount of data are collected by the sensor, and that can be transferred through the local network for the smart home server as well as the cloud computing technology. The next component we have to discuss is the processor. Processors are performing local and integrated actions. It may also be connected to the cloud for the applications requiring extended resources. The sensed data are then processed by the local server and it will provide the appropriate commands to control the devices. Next, APS, Application Programming Interface, which is nothing but a collection of software wrapped around with the APIs. So it will allows the user to access the processor very easily. Through this APIs only, the user can control the devices through the processor. So this APIs allows the sensors to access the data as well as the devices to execute the control. Next one is the actuators. So already we have discussed these actuators are used to execute the commands in the server and send those commands to the control devices. It also translates the commands from the server to the acceptable format of the device. Then only the device can understand what the command is given by the server as well as the user. Next one is the database. As we all are know, database is used to store the large amount of data. So here also we are using the database to store the collected data from the sensors. So for IoT applications, we may use any of databases like Oracle, MySQL, MS Access, whatever the databases we can include to store the data collected by the sensor. So these processed data are saved in our databases and that can be used for the further references. Next, we will discuss how these cloud computing technologies are used in the IoT applications. So before going to the cloud computing technology in IoT, let us discuss what is cloud computing technology. So cloud computing is nothing but a shared pool of computing resources ready to provide a variety of computing services in different levels, from basic infrastructure to most sophisticated application services. It can easily allocated and released with the minimal efforts or service provider interaction. So in general, very simple, we can say cloud computing manages the computing technology, storage and communication resources which are shared by the multiple users in a visualized and isolated environment. So, for automation of industries, the industrials are ready to spend more money, but that is not in the case of the smartphone because maximum of users not ready to spend much amount in the but to automate their houses because it has its own limitations in the field of storage, processing, communication, backup and recovery of data. So with this limitation, we can use the cloud computing which will provide the better processing for the automated smart process. It also provides secured data for the workflow. So, for processing the data which was collected by the sensor, computational task, we can use any one of these two methods to analyze the data. So, first method is IoT and smart home devices. Second one is cloud computing technologies. We can choose any one of this computation tasks based on the following parameters. That is overhead trade-off, data availabilities, data dependencies, how much amount of data transportations, how the communications dependencies and security considerations. Based on these six parameters, we have to choose any one of the above two computational tasks. So I would like to give you a small example for computation task with IoT and smart home devices. So this is already we have discussed a fan to control the fan. Yes. So to control the fan, the user from the remote place has to send the control signal to the smartphone. So this is one type of example for the IoT and smart home devices. Because here the control access are done by the local server present inside the home itself. Next one, cloud computing technology. So we will discuss where we are using this cloud computing technology. So this cloud computing technology may also be used in the healthcare services. So let us consider a doctor wants to monitor the patient who is living inside his home. But the doctor is placed in a remote place. From his place, he wants to monitor the patient because we know the medical data are more sensitive and it should be more accurate and it should be transferred to the doctor in a correct time. So it is one of the real-time applications. So for those applications, we may use the cloud computing technology to transfer the data and analyze the data because the medical data are highly sensitive and it needs more secure to transfer the data. And also to make our mobile devices suited for medical applications, it should be healthy data delivery. It should provide health data delivery, privacy, data security, and the data should be transferred or serviced in real-time manner. So we can use the cloud executions of multimedia based health services are needed for this application. So based on the application, we can select the computational task. Next, event processing. As we have discussed, in smart home IoT, we are using number of sensors. So that sensors will generate the massive data flow in the form of mass in the form of messages as well as events. So processing this data is above the capability of the human beings' capability because it will collect the large amount of data at a time. So we have to process all the events, and that event processing system has to be developed that it should be fastly response to all the events. So a centralized event processing system can process the large amount of events and execute the functions such as monitoring, navigation, and optimizing the process in real time. So, a centralized event processing system discovers and analyzes the problems and create the responses, such as it may be a warning or it may be an alarm to prevent the damage actions. Next one is for this evaluation process, which is triggered by the events delivery, the most recent state information is given to the user. That is, what is happened at last. The latest information is transferred to the user for the event handling process. So to handle these events, a language should be chosen effectively. So normally for IoT development or IoT application development, we may use any programming languages such as C, Java, Python, etc. Nowadays, industries may use the Python for IoT implementations because of its simplicity. So here, to handle the events, we have to select the proper language because event processing is concerned with the real-time capturing as well as managing with the predefined events. So it starts from collecting all the events and we have to find out the occurrence, identification the event and process the event, and that event should be responded in correct manner as well as the cost. For this, we have to choose the languages which allows the rapid and flexible event handling. For this, we are having the two different modules. So the first module is ESP module. So ESP module is nothing but event stream processing, which effectively handles the events, analyze the events, and select it appropriate adherence. And in a second module is the CEP, which is nothing but complex event modeling, which will manage only a group of events and produce the solutions for those events. Next, we will see the figure that will show the advanced four main components which are and their interconnectivity. So this figure shows you what are the main components needed to build a smart home applications and their interconnectivity. So first we can see on the left block side, it is a smart home environment. So here we can see the typical number of devices such as number of sensors and processors connected to the local area network, that is LAN. So this LAN enables the communications among the devices and the outside world. So the LAN is connected to the server and the databases. The server controls the devices, log its activities, and provide the reports to the users, answer the queries created by the users, and executes the appropriate commands to provide the control signal to the devices. And also the smart home server transfer the data to the cloud and remotely activate the tasks by using the application programming interface process, that is our APIs. In addition, these IoT home appliances are connected to the internet to send the data to the remote user's smartphone. So this internet allows the end user to communicate with the devices present inside the smartphone to get the current information and remotely activate all the tasks. That is, remotely you can give the commands to all the devices. So next one, this figure will show you how the data will flow for a smart automated home connections. So as I told you, it consists of the number of sensors. So first the sensors collects all the data and give those data to the event management system. So this event management system processed all the data and give the information to the user through the cloud computing technology and the internet. Using the same way, the user can send the commands to control the devices present inside the smartphone. So this layout gives you the clear idea about how the data is flow for smart home connections. Next, I would like to say you what are the information needed for a perfect IoT platform. A smart IoT platform should contain the following parameters. First one is it should be more secure as well as authentication. And it also have message brokers and message queuing. It should have a proper device administration, proper protocols for communications. The data should be properly collected, visualized, and it should be properly analyzed. And this IoT can be easily integrated with the other web services. And it should be scalability and user-friendly APIs are used for the real-time information flow and also open source libraries are needed to access the IoT application. So these are the main things needed to develop a perfect IoT platform. Next, here we have listed some examples for the sensors which has to be used in the home automation. So the sensors like temperature sensor, water level sensor, air compensation sensor, voice and sound sensor, pressure sensor, humidity sensor. So as we all know, we can find out the temperature present inside the home or the humidity level can be sensed by using a single sensor temperature sensor. Pressure sensor find out the pressures present inside the food. Like this, we can use some other sensor to detect the conditions inside the to read the conditions inside the food. Based on this data, we can control the devices. Next, let me discuss some communication protocols which are available for smart home applications. So first is simple and cheapest protocol is the Bluetooth protocol, which is smart and low energy wireless protocol with mesh capabilities and data encryption algorithm. Second protocol is the Zigbee protocol, which is mesh for network, low power radio frequency protocol for IoT applications. Next one is Extend protocol, which provides power line wiring. Through this wiring only, it can send the signals and control signals to the appliances present inside the home. Next one is Zigbee protocol, which is a specialized protocol used in the secure home automation. Next, thread protocol, it is a royalty and also a free protocol for smart home automations. Next one is ANT, an ultra powered, low powered sensor equipped with misdistribution capabilities. We may also the protocols other than these protocols for smart home applications. Among these six protocols, Zigbee, Z-Wave, and Thread protocols are used in the applications by automating our home. What are the applications? Here we list the applications of the smart home. So a smart home have a security system, thermostat system. It has a smart switches, smart air and water quality monitoring system. You are not only monitoring the water level, the quality of air as well as water. The purity can also be monitored by using this system. Smart lawn and gardening management system. So nowadays IoTs are mainly used in agriculture management also. For our gardening system, it will show when we want to plant the water. Sometimes it automatically watering the plants. And it also gives the information to the user what are the fertilizers needed and how much amount of fertilizer needed by the plant at particular time. Next, we can also control all the home appliances like microwave oven, refrigerators, TVs, all the electronics equipment present in our home also easily controllable by using this smart home application. Next, I would like to give small introductions about how robots are used in this smart home application. So as per we have discussed above, a smart home environment consists of the large number of sensors. So we have to buy number of sensors from different places. The cost of the sensors becomes expensive. And also those sensors have to be placed in different places. So we have to manage those sensors. The power consumptions of the sensors also get increased. So to overcome such difficulties, we may also use the mobile robot. So mobile robot carries a range of different kinds of such sensor and such sends the surrounding information and send the data to the environment. That is, this mobile robot will collect all the data and send the information to the server. So this mobile robot can eliminate the possibilities of using a huge number of sensors and placing them in all the environment. And the communication, that is, the communications between the robot and the object can be done by using the MQTT protocol, which is most commonly used in the IoT platform. Then IoT things can directly control the devices by using this robot because the users send the commands to the robot only. The robot will automatically control the devices. So here I am showing you the simple robot architecture. So it is the IoT robot architecture which is very simple. Here are the car-like picture will have a robot, which will sensors are collected all the data from our house using Wi-Fi technology and send those collected data to the IoT gateway. From the IoT gateway, it can be transmitted to the smartphone of the user by using either local network or the public network. Using the same way, the user can send the command to the robot through the smartphone. So before going to the robot, we have to discuss what is this IoT gateway, why this IoT gateway is needed for the smart home appliances. An IoT gateway provides a bridges the communication gap between the devices, sensors, equipment, systems, and the cloud. By systematically connecting the cloud, IoT gateway offers local processing and storage, as well as it has the ability to automatically control the field devices based on the data input by the sensors. So this IoT gateway enables the user to securely aggregate, process and filter the data for the further analysis. It ensures that the collected data are generated by the devices and systems can travel securely and safely from the edge of the cloud. So this is why we need to use the IoT gateway. Next, we come back to robot structure. So this IoT robot structure is mainly classified into three different modules. So the modules are displacement module, sensing module, and communications module. Let us discuss these three modules one by one. So first one is the displacement module. So as the name itself, we come to know the displacement module is responsible for the movement of the robot. A robot wheel is attached to the motor, which is responsible for the robot movement from one place to other places. The motor also turning the electric energy into kinetic energy. for the better. Next module is the sensing module. So sensing module, as we know, it will collect the data from the external media and convert those physical data which are collected from the environment numerical value that can be acceptable form for the storage device and analyzing processes. Next one is the communication module. So this communication module provides the interactions with the user by receiving or sending the report images about the environment to the end user. Next one. How a simple IoT robot can be implemented for automated work. So by using Arduino Raspberry Pi, which can be used to transfer the information through Wi-Fi sensor using this MQTT protocol. And also a motor is used to control the robot wheels. We may also use the cameras, which will take the pictures of the home and it send the pictures directly to the user at real time. We may also use the cloud computing technologies for device data storage, transfer, and process as we discussed earlier. So here I will show you one video for 5 minutes that will give you how an automated house is present.
Tangama, is your screen visible?
Ma'am, your screen is not changing, it seems. The video is not playing, it seems, ma'am.
Ma'am, Tangam, ma'am, your screen is not visible. Your video screen is not visible.
So from this video,
Thangamam, your video screen is not visible.
sir,
Your video screen is not visible.
sir, the video is over.
Yeah, video is over, ma'am, but is it possible to play the video once again?
It's not.
Is it possible to play the
Sir, it's
video?
not
Yes,
playing,
sir.
sir. Sir, it is not playing. So
Sir,
no issues, sir. We can proceed with the PPT, sir, because it's not playing.
Ma'am, actually, you can play it. Open the video with the Chrome browser and play it.
okay, sir. I will show you that again. Always, we will just discuss what we have seen in this video is it can automatically control or open or close the door when the family members were away. The video also preheat the oven when the owner is come for cooking and make the oven is ready for cooking. It automatically turn on or off the light or any electrical appliances when the person entering and leaving the room. It also give the information to the user whether what are the things available in the refrigerator and what are the things not available. So what are the things needed to be purchased? That is also listed to the user by this ID smartphone. It also turn on the electrical appliances, music systems that from anywhere inside the kitchen. And also, it gives the alarm to the boy when the refrigerator door was not properly closed. Even it can turn on the office systems automatically when the user enters the office. It also gives the notifications about the visitors or some persons who are nearer to our home also. So by seeing this video, any of us having a dream to have a smart home like this. So as an engineer, we can also automate our home like this. So all of us to develop such automation devices. Even it has this much of applications and a benefit, it also has some challenges while developing the IoT applications in smart home system. So it has challenges on the field of audio if any wires get damaged, poor internet connections, and it is very difficult, it is somewhat difficult to coding and connections of different sensors. So this is about the small introductions about the smart home, how it is implemented by using IoT, and what are the things needed to develop the smart home applications. Okay. So this is nothing. This will give you. I think it may be useful for you. At least give a little bit idea about the smart home applications. So just I will show you the video once again because somebody's are not able to see the video, right? So give me a 2 minutes. I will show the video again. I think the video is visible now.
Yes, ma'am, it is visible. I think
Ah.
you can explain.
So as I already told you, the door is opened when the user entering the home, and the oven is preheated and make it ready for cooking. Here we can see the light and on and also it will set the heater. It shows the eggs are out of stock. So it gives the information to the user what are the things required. Even it shows the speed limit of the car. So it gives the notification what are the things not available in the home. It is garden management. It shows the irrigation need of the plant. Also lawn management. automatically close the door and also switch off the lights. Now see how a smartphone can change our life. This is the one day work of a smartphone. So thank you for listening to this webinar part, last one. I think you will get a little bit idea about what is a smartphone, how IoT works. Thank you very much.
Okay, so thank you very much, Professor Tangam. Do you have anything other things to share, ma'am?
No, sir.
Okay. So I think there is one query from the participant side. Hari Krishnan, he has asked about. Can you tell me about sharding? No, Hari Krishnan, is that your query all about? Okay. Do we have other questions or queries from the participants? Other participants?
Ma'am, do you have any experience related to this work? Whether you have applied for any funded projects or you are working on this project?
Professor Tangam, there's a query from Dr. S. Amuda.
Ah, yes, sir. So,
Yes.
ma'am, actually, I'm not having that is develop any applications, but I had a 1 year experience. While doing that, I have developed the software for the protocols development that is used for MQTT protocol, which is used for the communication.
Okay, okay, ma'am. Thank you, ma'am.
Thank you.
Okay. So if there is no query from the participants, we'll move on to the next session. Sir, Prabhakar sir, can we move to the next session?
Yeah, sir, we can move to the next session, sir. Sir, many participants, they're joining the second link.
Okay.
Can we start accepting the second link, sir?
Yes, sir. I have received some queries regarding with the second link. Just be patient for a while. We'll try to create another
Okay.
link. We'll try to create another link. I'll come
Okay,
back
sir.
very shortly. I'll come back very shortly.
Sure, sir. No issues, sir. So
Okay.
we can start the second session, sir.
Okay. Right. So thank you, Professor Tangam, for your extensive knowledge sharing on IoT, and we got an overview about how IoT works and your example with regards to this IoT amidst this pandemic period. So thank you once again, Professor Tangam, for your valuable knowledge sharing. So we'll start up the session with Professor Arul Rajan. So before going into the session two, uh, we would like to remind you once again that certificates shall be issued only to the registered participants who have submitted the feedback. Right. So about Professor B. Arul Rajan, he completed his BE in 2002 from Adi Parasakti Engineering College, Melmarvatur, and completed his ME in 2007 from SSN College of Engineering, Kalavakam, Chennai. Currently, he is pursuing his PhD in part-time from Anna University Chennai. His area of interest includes communication systems, and he has worked in Vihan Networks Limited, Gurgaon from 2010 to 2015 as senior engineer. He has published several papers in reputed Scopus and SCI Index journals, and we are privileged to have an industrial come technical person who's also a teaching faculty working in EC department, Electronics and Communication Engineering at St. Martha's Engineering College, Thoothukudi, India. So warm welcome to Professor Arul Rajan. Arul Rajan sir, the screen is yours.
Yeah, good morning to one and all present here. It's my privilege to handle the second session. I'm happy for the opportunity given by our management, SCAD group of institution, the chairman sir, our vice chairperson, our MD and others, especially our principal, Mr. George Clinton, and our HOD, Mrs. Tangam. And I thank Professor Christo Ananth for the introduction. I hope the PPT will be visible now. Yes, is it correct? Is it okay? Are you able to see
Yes,
my
yeah, it's visible, sir.
Yeah, yes.
Yes, visible, sir. Sir, can you make it full screen, sir? Thank you, sir.
Actually, I was working previously in a telecom-oriented company, to where these automated tests are being made with many softwares. One of the software which I am going to explain today is using MATLAB. Right? And many of our teaching community, even the students who are present here, may not be having a thorough knowledge or a basic knowledge. What are the fields which we need to improve, or what are the things that can be done through MATLAB? Even many know MATLAB, I think, in this place where you are here. So many may know more than me about the MATLAB, how to use the software, but how to use the same MATLAB for automated tests. So that is what the today's talk about it. And today, before going to start about this automated testing, we should know a field where engineers are deployed for test and measurements. Most of the electronics company prepare their PCB boards, and they give them a thorough testing, and they measure various parameters out of it, and based on the parameters, and they have some limits. If the values are coming correctly, then they say the board is tested okay. Otherwise, some modification need to be done in the board what kind of modification that the RF engineer will take care of it. The RF engineer has to look into what went wrong and why I am not able to get the optimum value which is necessary for the proper functioning of the circuit. So this is one of the important thing. Along with RF engineer, the person who takes care of test and measurement, most probable case of an RF engineer, he starts with test and measurement. So we have many tests based upon the, since it was an telecom company, I used to work on various protocols like GSM testing and various other things, right? So we have so many factors there are so many factors which need to be tested, which we will see one by one. To start with, what is a test? A test is a commonly defined as a tool or instrument of measurement that is used to obtain data about a specific characteristics. So, and then we need to know about the test and measurement. Many of students doesn't have this knowledge of test and measurement, and how they are simply having some experiments to do, and they are just going and finishing their degree. But how the entirely the academic and the industry are entirely different in my perspective, and we need to impart what is actually required by an industry. Test and measurement equipment underpins the product design process. So whenever they produce a product, they go for a rigorous testing, and this enabling the engineers, they have to verify um, their design with this test and measurement. And this verifying the design is working in the way they want. Usually, they first prepare a board, and they will send it for testing, and the test engineers will test their those boards produced by the the production team. Then if the values are, and they will take the values, send it to the RF engineers, and the RF engineers will find out whether it is actually good enough for proper functioning, and whether they are getting the optimum value or not. And if it is not, these essential devices help them to find out where the problems lie. And based upon the results, they will actually find out which part of the board or which part of the circuit PCB they have to make corrections so that the proper functioning can be done. And previously, before in the olden days, we had electronic tests, and based upon this electronic test measurement equipment, so we have so many measurements. Like if we take a CRO, it is that is cathode ray oscilloscope. It is simple, and it is a time domain way of analyzing a waveform, right? And there are other equipments as well as, and we have in frequency domain we have spectrum analyzers and so on and etc. And there are many different form of test instruments that can be used for test electronic equipment. So one of the basic one is a digital multimeter, which most of us use. And there are many other test items which we are not using in our day-to-day life, and there are oscilloscopes which we have in our colleges and universities, and even in the companies. The only difference is the range, the operating range will be different. We call it as function generators, and then the spectrum analyzers, with which we can see the signal in frequency domain, and we can analyze in a better way. We have another logic analyzer, and many more are there. These are the things which commonly used for electronic tests and measuring purpose. What is electronic test equipment? Actually, electronic test equipment is the one which is used to create signals and capture responses from electronic devices under test. We simply call it as the DUTs, and sometimes we call it is a UUT also, that is a unit under test. Electronic test equipment is the one which creates the signal. I mean, here it plays the role of a signal generator, right? And then the one which captures, that is what we say a CRO or a spectrum analyzer. The proper operation of the DUT can be proven, means we can test it, and based upon the results, we can say it is 100% working correctly. And even if it is not working, we can find out the fault. We can find out the faults in the device, and that can be easily traced. Use of the electronic test equipment is essential to any serious work on an electronic systems. And now comes our the heading, that is the title of our today's talk, automatic test equipment. What do you mean by automatic test equipment or automated test equipment? Simply we call it as ATE. It is any apparatus that performs a test on a device. It's an apparatus, right? We call it as the one is DUT. Just now we saw a device under test, or sometimes it's called as equipment under test, right? That is the board which we are going to test. That we call it as equipment under test, or the unit. We say UUT, unit under test. These are the things which are used for automation, for quickly performing the measurements. Right? And based on the measurements, we will compare with the actual value which we need to get, the desired one, which we need to get, and we have to evaluate the test results. The same ATE can also be simply defined as computer controlled a digital multimeter. It may be a digital multimeter, or as I told before, it may be any other device like a signal generator or an oscilloscope. Oscilloscope or spectrum analyzer, logic analyzer, etc., or any complicated system containing dozens of complex test instruments, real or simulated electronic test equipments capable of automatically testing and diagnosing the fault in sophisticated electronic packaged parts or on wafer testing, including system on chip and integrated circuits. So this is basically the definition of ATE, that is automated or automated test equipment. And why we that what is the reason why we need to go for this automated testing? Why the manual thing we cannot do? And if you think of on a manual, an RF engineer taking one board and testing, doing his measurements manually, then it will be very difficult. And it not only very difficult, there are some disadvantages which we will compare after a few slides. The first one is cost efficiency. The cost will actually increase because it's a slow process, the manual testing is. And then the second one, if you want to perform it as a large scale, means I have hundreds and hundreds of boards waiting for testing. A person or a multiple number of persons cannot do the task very easy. So that's why we prefer ATE, that is automated test equipment. And then we call it as turnaround time, how much time it takes to test a board. So in case of manual testing, which will take much time, whereas the automated test equipment will take lesser time, and that is why it's a faster turnaround time. And manually, it may be, we call it as human error. There is a tendency of accuracy level which may go low. So for to maintain the accuracy level, which is most important for industrial case of testing a particular board or PCB, then we should go for automated test equipment. Manual testing maybe tested for 1 or 2 boards, that's okay. But if you go for multiple number of boards, and that too at a very large scale, then we have to go for better accuracy, right? That's a very important thing. Practically, every electronic engineers and the assembly requires the use of many different kinds of electronic test equipments, ranging from very simple and inexpensive. If you take a very small example, right? I want to just test whether the bulb is glowing, whether it's working fine or not. Then I need a simple circuit. That's why I told it's a very simple and inexpensive one. Such as the test the light consisting of a bulb and a test tube. Right? Normally we used to test, even if you go to the shop, the person who is in the shop, electrical shop, will just show you whether the bulb is glowing or not. So that we cannot say after bringing that bulb to home, it's not working, we cannot go and return back. So that's why he's showing to you that it's glowing fine. Extremely complex, and then this is a very simple one. And the next level, slowly the complexity is getting increased, and once the circuit becomes very complex, it's not easy to test it manually. So that is why we go for the sophisticated way of testing, that is automatic or automated test equipment, ATE. The automated test equipment often includes many of these instruments in either real or in a simulated form. Now, I'm just going to compare the differences between the manual testing and the computer-based, that is automatic testing. The first and most important one is the accuracy. The accuracy level will be less in manual testing. That's why it's written there is a tendency of human error. The manual testing shows lower accuracy due to the higher possibility of human errors. At the same time, the automation testing or automated testing depicts a higher accuracy level due to computer-based testing, and this eliminates the chances of human errors. The second criteria, when we compare these manual and automated testing, manual testing requires more time. It needs time when testing is needed at large scale. Whereas in case of automation testing or automated testing, which we can perform easily testing at a large scale with utmost efficiency. As I told before, the turnaround time for manual testing, this will take higher amount of time. Similarly, if you take an automated test equipment, here the cycle of testing will take lesser time when compared with the manual testing. And as I told previously, we have a cost. The cost plays an important role in the production, electronic, we call it as electronic production, we can say, circuits, right? PCBs which we create for a specific purpose. This manual testing normally needs much cost, as it involves the hiring of expert professionals to perform testing. So actually, the RF engineers are there to test each and every board, but we need, if you are having a large scale, a large amount of boards which are in queue, which need to be tested, then we require a large number of experts, right, RF engineers. Then it is we have to pay more, and that's why the cost is also increasing. Right? But whereas in the case of automation testing, now we have the RF engineer present. The RF engineer will write a code, or the person who is there, which will take care of this automated, which creates the writes the code or the scripts, which will create the automated testing routine. This saves much cost incurred, as one of the software infrastructure is integrated. It works for a longer time. Means suppose a person is doing just some testings. I will show it at the end of this lecture how to use the MATLAB not only MATLAB, but you can use many softwares. But I'm going to show only about MATLAB today, um, which requires much time. That's why I prefer only MATLAB. So here, which requires it works for a long time, means we can use it for hours and hours. Suppose I am going to do some other testing, right? I will automate this testing, and that board will be kept on testing, and which will give the result. Even say I am started the testing around 8 p.m. in the night, and I'm going for the sleep. The RF engineer is going for the sleep, and the next day morning he comes and just check the computer, which is connected with the various devices which need to be performing the measurements. Automatically it will produce the results if it is working fine, right? So by this way we can but manually it is not possible. RF engineer has to sleep, then only he can do more automation, right? So that's one of the cost efficiency is also taken into account. And the user experience. The manual testing ensures a high-end user experience to the end user of the software, as it requires human observation and cognitive abilities. Right? So, suppose I hire a person, that RF engineer, and the RF engineer is taking care of that particular testing, right? And this is a manual testing, and which we require every time we have to measure a particular we have to take a particular instrument which we can use it for measurement, and with the help of that equipment we can measure, right? But it's not a repeated one. If I want to do it for the same procedure for multiple number of boards, then it is a tedious job. So automation testing cannot guarantee a good user experience. Now we have a disadvantage of good user experience, since the machine lacks human observation and cognitive. If we are it's like trial and error. The first time when we create an ADE, it will have its own some flaws, right? And then by seeing the results we can fine tune so that the automation of the automated testing equipment, that is ATE, which can be made superior level compared to this manual testing. And where these manual and automation testings are done, manual testings are preferred. This should be used to perform exploratory testing, usability testing, and ad hoc testing. This exhibits better results if we do these testing in a manual testing, right? But certain testing which require automation testing, which we cannot use it with the help of manual testing. The automation testing should be used to perform rigorous testing, load testing, performance testing, or the same thing is again and again repeated. That is repeated execution. Suppose for the first time when I run, I am getting some values, right? And then these values are compared second time, third time, whether the same results are getting, I am able to get or not. Even in companies, we call it as chambers, right? There people used to keep in a high environment. These boards are kept under high temperature level because, for example, certain cases like countries like India, Africa, and other countries where the temperature level is high, so there the PCB or the board should withstand temperature and it should not have any problem in producing the result. So that's why we do rigorous testing, and we do it repeatedly, and n number of times the tests are being done, and that is possible only with the help of automated testing. And the most important one is the user skills. The user must have the ability to mimic user behavior and build test plans to cover all the scenarios. He has to take it into account. An RF engineer, the user is the RF engineer who has to have the ability, right? Suppose one person is an expert in that preparing a testing and testing the boards, right? And the next person who is having less experience may not have that much knowledge or that much same experience. he cannot find out all the mistake in the beginning stage. Later stage, after getting some prior experience, he may go for thorough knowledge, so he can perform the testing operation in a very good way. But whereas if you go for automation testing, here the only thing is the user need a highly programming skills. So here the software that is like MATLAB, like LabVIEW, Python, etc., so many software available which can be used to build an AT, that is automated test equipment, and the scriptings with various test cases. There are many tests which may not be required to repeat for n number of times. But for the first time, we can say that testing can be done. And some tests we need to repeat for the n number of times. Then we can choose, we can do some settings so that a particular test can be repeated again and again. A particular test which we can avoid in doing performing multiple number of times. That's why there is a scope for the person who can develop a code, either in that we call it as a programmer, we can say a MATLAB programmer, or even any industry. Many industries like even there's a what we call it as Agilent. Nowadays they change the name as Keysight, and so many other companies, MNCs. They are very popular in the electronics market. They require people who have the knowledge, programming knowledge, to create this automated testing, and that is why, that is with the help of developing that ATE, it is easy process instead of going for manual testing. Okay, so now we are going to see about how an equipment or an instrument is being connected to the computer. Right? So we need to, the computer, we need to program the computer how to connect to the, we can say, simply say, we can, how the computer can talk to the instrument, right? It's like talking means the computer will throw a command to the instrument, and the instrument has to reply back, right? That we call it as talking, right? Like just like human talking. Here, the computer has to send a command to the instrument, and the instrument which is connected to the board will perform the measurement, and it will send the result back to the computer. So here, this instrument control overview in this slide, this type of connections, there are many connections available, which we will see in the next few slides. The type of connectors, normally we know only the USB level of connection, but in industries they have a variety of connections, which we will see in the next slide. Right? So types of cables used, that's what we call it as this color, this connection is either through cable or different type of cable can be used. And what is the communication protocol? There are so many well-defined protocols there which can be used for extracting the information which are generated by the instrument, and this will be sent to the back to the computer. Right? I am operating here, and I want results from my, this board is connected to this equipment, instrument. It will measure and send back the result to the computer. So this is nothing but a DMM, right? And this is a, this is an, I think, yeah. And this is a MXA, we call it as a spectrum analyzer, right? And for this purpose, we have many softwares. Softwares in the sense, if you take NI, that is National Instruments, they provide a software called MAX, NI MAX. Okay, Measurement Automation Explorer. So that's what they call it. Like that, so many others. In MATLAB also we have IDI and other, even say we call it as drivers, which are used for specific cases, right? In the olden days, before, some few years back, around say 10 or 15 years back, in the beginning, they used to have this serial communication, which is nowadays being replaced because the speed level is a little bit slower. As it's given here, they used for lower transfer rate. This is one of the popular communication between the computer and the peripherals. And here, data are sent bit by bit, that is one bit at a time, across the cable, like this, right? So that's why it's slower when compared with other communication protocols. Only a cable is needed, since most computers have at least one available serial port. Say we call it as a serial port or RS-232, right? RS-232. So in the olden days, we have instruments with that serial ports. Nowadays, even laptops are not having those serial ports. They are replaced with USB ports, which are very popular. So they are not having that we call it as a DB9 connector, which we normally even use it for connecting the monitor to a computer. Right? So this RS-232 plays an important role in the olden days, but it's slower. So that's why we go for the next way of communication, how we can communicate with the instrument. So here, these equipments are using the GPIB communication protocol, and that's why we call it as GPIB instruments. And these are connected to the computer by the help of a GPIB cable. We have some specific cable which we can connect it to the computer. Even the computer will have its parallel port. Through the parallel port, we can connect it to the GPIB. Right? So GPIB, that's a very important one, which is widely used in almost all manufacturing industries, which produces these PCBs, right? So this is the history of the standards, starting with the 1965. Previously, the company, the MNC, which we called as Hewlett-Packard, started their journey of producing this, how we can connect to a particular instrument. They created this interface bus, even this GPIB. IB stands for interface bus, right? So first in the beginning we call it as HPIB, because with their own company name they call it as HBIB, and then later this is standardized by IEEE, and they call it as IEEE 488, and even that is modified 488.1 and 488.2 in year 1987. And there comes the next level, the most important one for any programmer who needs this set of commands, right? We call it as commands. We call it as SCPI or SCPI, that is standard communication, standard commands for programmable instruments. Means I have a equipment. That equipment, if I throw that command to that equipment, it will respond to the computer, right? That's what we call it as SCPI. The command is being sent from the computer to the equipment, the instrument, using this SCPI, that is SCPI. And even this 488 is first adopted and then revised in the year 1992, and it is changed to 1993. It's HS488, and then in 1999, like that, journey goes, right? So most of the companies require a standard protocol, a standard communication protocol. So that's why they preferred a general purpose interface bus. That is what we call it as GPIB. So there are other things, like as we just saw, serial and GPIB. We have other two, that is VXI and PXI. This is mostly used by NI instruments, NI, that is National Instruments. And when we talk about this visa, visa is in general we call it as if we want to go for a country, another country from India, then we need visa. Like that, if we want communication to be established between a computer and equipment, then we need this environment called VISA. Right? So it's a software architecture, and it is virtual, and that's why we call it as virtual instrument software architecture. And this virtual instrument software architecture is platform independent. And this plays a vital role. It's a backbone of IVA. That's what I told. This is one of the things which is widely used by even MATLAB. Plug and play instrument drivers. And these are platform independent, but whereas it is interface independent also. Platform independent as well as interface independent. Only the programmer or an engineer who want to test, he want to make the test automated, he has to prepare an ATE, build an ATE with the corresponding SCPA commands. Suppose if I know a particular equipment, then the equipment will have its own manual. We call it as programming manual, where these SCPA commands will be there. And what kind of commands we can throw with the help of that manual, we can understand. And by throwing the command to the equipment or the instrument, we can get a reply back to the computer. And this is possible with the help of this virtual instrument software architecture. And now we are going to practically see how an AT can be built. Actually, due to shortage of time, I cannot show you the entire how to build. There are many videos, even in YouTube. You can watch how to build an AT with the help of MATLAB and with the help of the graphical user environment, which is available in the MATLAB. Now we are going to actually MATLAB to see how the AT can communicate, right? Communicate with the instrument, get the values which can be measured with the the boards, that is PCBs, right? Just a minute. I'll share some videos which you can see it. And in MATLAB, we have one toolbox which we call it as a instrument control toolbox. I hope any of you are familiar. And just to know what is meant by instrument control toolbox, I'll play this video. It will be for only 1 minute, 2 minutes, right? Are you able to see the video? Excuse me. Excuse me. Is it the audio is clear, or are you able to hear the audio?
Yeah. Your audio is clear, sir.
I mean the video, the audio is there.
The audio of the video is not.
Okay.
We cannot
Just
hear.
a minute. Just a minute. I'll share it in the. Just tell me whether the audio is clear or not.
Okay.
I just missed this TCP IP, which is nothing but the LAN connection. Even some equipments, most of the equipments have this LAN connection. That is, we call it as TCP IP. Even you can establish a connection, this LAN connection between a computer and the instrument. Without if you don't use it for, you have a GPIP. If there is a provision of LAN connection, then you can use a TCP IP also. Actually, here, if you see here, there are built-in commands inside the MATLAB, see, this is a serial port, the COM5, right? The COM5 is a serial port, and I have an instrument that the company is Tektronix, and I want to Tektronix oscilloscope, right? So I want to establish a communication between my computer and this Tektronix oscilloscope using the serial cable that is COM5, right? So this is one way. This is actually slow, as I told before. This serial communication is slower. That's why we go for the next one, that is GPIB. And then we are creating a connection, right? And then we have to open the connection, right? Here it is actually configured here. And then what is the data I can read from the equipment with the help of this function called scope read waveform, and we can even plot the waveform, right, in the computer. And once the measurement is done, we have to disconnect and clear the scope, right? This is the simple script how we can program using the skippy commands, right? Here there is actually there is no skippy commands. I'll show you. Actually, this is the instrument control toolbox. If you just a minute, this is the command window of MATLAB. That's a command called ver, ver, right? So if you put this ver, it will show what are all the toolboxes which are available or installed in your computer. You have to check whether this instrument control toolbox is properly installed. Otherwise, you cannot communicate with any equipment. So first thing is you have to check whether this instrument control toolbox is available or not. And then the next one is, there's a command TM tool. So TM tool, if you put, it will open this kind of test and measurement tool, right? So it will create this. So if you want to create a serial connection, just right click and scan for equipments. Actually, I have not connected since I am at home. I am not connected with any equipment. So even if I scan, it says there is no serial ports found. But if I am connecting with the, connecting any equipment which is through a serial port, then if I scan it, automatically it should say that there is a connection and through via the port. And if I want to connect through a LAN, right? There is a LAN connection that can be made between the computer and that equipment. So that is through this add new TCP/IP instrument. If I know the IP address of the equipment, then I can add it here. And if I want, I can add the port also, and then create a connection. You can establish a connection through this TCP/IP. And there is UDP is there, Bluetooth is there, I2C is there. These are all various interfaces. And then the most popular one is GPA, as I told before. GPIB here also, since it is nothing connected, so it will not show anything. GPIB, right? And then the most important one, VISA, right? As I told, Virtual Instrument Software Architecture. So here, this is the inbuilt, inbuilt what we say protocols But whereas this visa is another way of connecting uh, the equipments, right? So if it is VXI, I mean the equipment will have its own specification, and based on that I can use any particular drivers or particular thing. Even say GPIB VXI means then I have to create this. If I scan itself, I'll automatically get. If I'm not able to scan, then I have to go for creating that. I can write the code, um, but at present I can show you this only. And then the next one is measurement. What are all the things connected that I can see it here. And apart from that, drivers are available. MATLAB instrument drivers, we call it as, and other drivers like VXI plug and play and IVA are available. The inbuilt MATLAB provides this basic equipments. As I told, this Agilent. Agilent is now renamed as Keysight, and this is having inbuilt drivers, instrument drivers with MATLAB instrument drivers, which we call, which will have the extension MDD. That is a MATLAB device driver. And this Agilent E33648A, if you give that equipment, it will show the what is that particular equipment. And if you know the Skippy commands, you can directly talk to the instrument and it will reply. Not only Agilent, there is Lecroy, Tektronix. All these companies are providing inbuilt available in the MATLAB itself. Right? So you see the video, remaining video back. So this is one video which I want to share. Another video, how you're going to measure
Sorry, Professor, I was to interrupt you. You can just explain about the things that you are doing in this week.
Yeah, yeah. Just a minute. I'll share you. Actually, this was the one of the automated test equipment which I developed during my the company where I worked. So just I want to show you how the AT will look like. Actually, if you want to create a GUI, then you have to type a command called guide. This guide actually it will open with asking whether you want to create GUI, and you can even open the already created one. This is the one which was created by me in the old company where I worked. So here I will show you. This is one of the AT, how to calibrate a BTS with the help of this ATE that we used to do. Right? So we have so many other small modules, like we say call it as RTM. We have power amplifier. We have duplexer. We have so many other things, and these from those boards we have to measure what is the temperature value, what is the version, what is the model number. All those things we have to do, and then here are the measurements, right? So here, what are the measurements? Trim part, trim IQ model. These are the various measurements. Which one I want to do? I have to select. Then by selecting, then I have to press run, right? So this is the running the automated test equipment. And here, so I can fine tune and what value, optimum values that we call it as control file. This control file, which optimum values I require, depending on the boards, I have to select this one. And then the one of the how the connections are made. So this is a setup. This is the one which connects. So when I say setup, if I click here, it will open up this and it will show you through what are the ports I'm going to communicate. For example, I have 10 ports and I am communicating through port 1. So I have this already, we call it a CP console, and we have another console called DSP console. These are on the boards, and I am connecting those things to the AT, right? So I have to choose the correct one so that I can establish the connection. Similarly, if I want to have a connection to a spectrum analyzer, then I need to say, for example, EXA, that is Agilent, or the Keysight. Nowadays we call it as Keysight. It is there's an instrument called EXA, and this EXA equipment can be connected through either LAN. LAN means I have to give the appropriate address. This is the address of the equipment. So the same thing, approximately my in the same domain, my computer also should work. Then only I can make the connection, right? That's LAN mode. Now another one is GPIB mode, and I have to feed the GPIB address and what are the power levels in dB. I have to mention here, and based on the frequency, it will pick. So this is the settings, right? So and when I say run, see here. I don't know whether the code is working because I have not connected to any equipment. When I say run, it is showing some error, right? But actually, it should work since it's not connected to any equipment. So now it's saying some error. But actually, see here, when I say run, it is running now. So it will measure, it will show all the values, right? So like that, we can measure everything, and even it will generate CSV files. It will generate various CSV files, and all the data we can see it in the CSV files. What value it is measured, what is the temperature, what is the hardware value, what is when it is that PCB is tested, the production date, all those things we can measure here. So this is a simple AT. There are so many ATs. If you in another situation, if we had an opportunity to go for another lecture, then we can have one more lecture how to develop an AT. Thank you for the time. Thank you once again for everyone.
Thank you, Professor Ananth, for your
If you have any
intensive.
questions.
Yes, there was some interference. Somebody. Okay. Right. So, thank you, Professor Ananth, for your intensive knowledge transfer on automated testing, especially using MATLAB. And we have some queries from the participants even.
Yes, sir.
Arun Kumar has asked what is the usage of MATLAB and why is it popular?
What is it?
What is the usage of MATLAB and why it is popular?
Why it is
Popular.
popular?
Yeah.
Actually, now it is Matrix Laboratory called, right? MATLAB is a software, even though it is um, it's not only used for one particular branch like electronics and communication or electrical. It is used by, it has so many toolboxes available. Even an electrical engineer, electronic engineer, even computer, even image processing, like a mechanical engineer, not only engineers, even statisticians, like that. So many other toolboxes are inbuilt inside this MATLAB. So that's why it's more popular, used by many people around the world.
Okay. Thank you, Professor Ananth. There's also another doubt from Dr. Pallavi Murgai Goel. The doctor has asked, so TCP IP is oldest to you in companies. Can you guide how OSI actually implemented in companies?
TCP/IP.
TCP IP is oldest to you in companies. Can you guide how OSI actually implemented in companies?
OS means network layer you are talking about, right?
Yes.
Um, Actually, this TCP/IP is the one way of communication, right? If you talk to a network, then it should have its own proper network identification, and then if you have a proper network identification, that need to be given known by the our computer, the person who is operating the computer. Then only the communication can be established. This is the way.
Okay. Is there any more queries from the participants? You can switch on your mic and you can ask your query if you want to.
Yeah, you can use Python. Uh, it's not like that. The MATLAB is equally good, but Python is more popular nowadays. It's not that you cannot create a ATE with MATLAB also, and depending on the application in which you are working, MATLAB is an excellent tool in signal processing. So it is widely used for this kind of electronic way of testing. It's not that the ATE cannot be developed with the help of Python and other languages, but that is also possible.
Any more queries from the participants? You can still use your chat box or you can on your mic and you can ask your queries. Any more queries, participants, dear participants? Okay. So the feedback link has been posted to you in the chat box. Feedback link 1 and feedback link 2 of session 1 and session 2 has been posted in the chat box. Once again, we would like to repeat the certificate session materials uh, and the everything with regards to the session 1 to session 12 will be posted to your registered email ID within 1 week, that is 18 May 2021. And I request the participants to refrain from grading each other using chat box or to the speaker even, and keep your mic in off condition and use your mic only if needed. And we can start the session, the evening session at 5 p.m. Indian Standard Time. Of course, you can refer to the schedule if you belong to the other country, whether maybe in Bahrain or maybe Saudi Arabia or maybe Ethiopia or any African countries. You can refer to the standard times if you wish to. You should have received your mail even Dr. Prabhakar has shared this useful information once again. So session 3 starts at Indian Standard Time 5 to 6 p.m. Ethiopian International Time 2:30 to 3:30 and Ethiopia Local Time 8:30 to 9:30. And session 4 Indian Standard Time 6 to 7, Ethiopia International Time 3:30 p.m. to 4:30 p.m. and Ethiopia Local Time 9:30 to 10:30. So thank you once again, participants, for your cooperation amidst this COVID-19 phase 2. So thank you one and all. Dr. Prabhakar, you want to share anything, sir?
Yeah, sir. Thank you for Arul sir for your informative presentation, sir. It is
Thank you.
fabulous. Thank you.
Thank you, sir.
And thank you all the participants. More participants are joining in the first session, and we are unable to join some participants to allow. So in afternoon session, I think all the issues will be solved. So thank you, sir. Thank you to one and all, and thank you to Dr. Christo, sir, because he is the backbone for this event. So I thank personally Christo, sir.
Yeah, it's okay, sir. No mention. We shall be definitely in contact and we shall conduct further more events. So once again, I have posted the feedback link for your kind notice in the chat box. This is for your kind information. So thank you one and all.
Thank you, sir.